fixed effect. So, so you can see different firms going to have a different, we say the investment level, right? Different firms have a different investment average of the different the levels. How we going to interpret this, for example, right? Well, the important thing is how we to interpret, right? So we can see, okay, this is the coefficient, right? Constant, and then slope coefficient for the VAL, CAP for this 10 firms. But how we going to interpret? Are they different or not the result? So this is my based on this pool OS. So in my pool OS, my constant is negative 43, but my how we say this fixed effect is negative 58. Slope coefficient for the CAP is 0.3. Then from this pool OS is 0.23. Right, VAL is 0.108. Then VAL in the pool OS is 0.1149. So even though it's not much big difference, but the implication difference, right? Because if we focus on this fixed effect, so for example the CAP, right? So increase one in the CAP will increase the investment by 0.3117 instead of 0.233. So there is an implication. So you cannot say they are same. 0.3 and 0.23. Actually, they almost is positive, right? Yeah, that's positive. Same sign, but the size, the magnitude means that the size of the implication on the investment totally different compared these two models. Even though they are same behavior, it's a positive impact, but the coefficient 0.23 versus 0.317. So after we take into account the individual effect. So this is our pool result. This is our individual effect. It means I take into account the fixed effects across these 10 firms. So how we estimate with the EVs? So if you're successful to estimate the pool OS, I don't think it's a problem for you to proceed to the fixed effect. So you just go to the estimate and then choose the fixed effect random, right? Fixed and random effect, the estimation method. So you can choose here the cross section, you put fixed. We are not going to touch on the period. We are not going to estimate the two ways. We just touch on the one way. These are mostly used in the research, right? One way is fixed effect. So cross sectional, I put fixed. And then other than that, I just remain same. Then you can, okay, see what will happen. So this is my result. So this is my result. Again, I go to estimate. Then all the things remain the same. Dependent variable is investment. And then independent variable, I still put under the common coefficient. CAP, VAL, question mark C. But the cross-sectional here, I want to, what we say, estimate the A0, right? A0I. Now it's A0I, right? A subscript 0I. So that's why the cross-sectional here, I put fixed. I put fixed. It's not random, it's fixed here. Then I click OK. So this is my result. So here, same, right? Same result. So how we interpret? How we interpret? You can see the coefficient, standard error, test statistic, p-value, all similar, right? Yeah, like what we discussed just now. And then how to interpret this fixed, right? So you can say the average intercept, right? This is the average intercept. Negative 57.45. How I get negative 54? Negative 57.45. Let me see. GM. Oh, this one is for So there is this fixed effect, okay, this fixed effect for the individual firms, okay. So how we interpret this one? Let me see, yeah. I think we have an interpretation. How we interpret? So we can use the average, right? Average interpretation. I think for my next week lecture, let me see my next week. Just 7. Okay, this one, this one. Oh, this is another version already. This is the next one. This is oh, aspirin. This is the final injury already. Models action. Ah, let me see. Oh, this one we're going to handle next week. The one to touch on this one also. Okay, so we just this one just want to show you the fixed effect. So next week we're going to calculate the things right? To test it whether there is a fixed effect or not in the regression in this exercise. So now I want to go to this explanation for this what we say the fixed effect or random effect models. Okay. So now we want to proceed, right? Proceed. Just want to showcase you the random effect. So what is random effect models? So random effect. So this fixed effect, right? Assume this each group has a non-stochastic group specific component. That's why you can see just now we estimate, right? So that's why you can see all each firm is going to have a different intercept, right? Different intercept. So, but under these random effect models, or another name called as error component models, actually this unobserved effect may be stochastic. Because it's an unobserved, right, and it's stochastic. So this random effect model, they something like treat this AI unobserved component as a component of the error terms. So the AI here is not appear in the intercept. So we'll treat it as this one as a component of the random error terms. So these two is combination become BIT. So what's that? So this is unobserved component, right? Just like we will say the individual fixed effect unobserved is unobserved, right? Together with this original residue. This is original residue. So it's an element of the means that the varies across this over the group and time. So this is called BIT. These are components error terms. So this REM, right, random effect models assume the constant is a random variables. So this assume that it's a random variables. So we're not going to touch going to do anything with this constant. So the AI here is appear at the back here already under random effect. So how about the intercept? So how we compute the intercept of individual? So because we treat as a random, right? So the beta 0 I here actually is a beta 0 plus the AI. So it will be beta 0 plus the AI. So this one plus this one. So just refer to the intercept for the individual. And how about the composite error term, the VIT? So actually it's the AI plus the UIT. It consists of the two components. One is the AI, the other one is UIT. UIT is the specific error component. It's in the original one, right? Original model. just like your fixed effect also got UIT, right? But now you have the VIT here. So this VIT is included this AI. So this AI is a cross-sectional error component. So it's actually referred to this individual fixed effect, okay? It's between as a random, right? As a random. So there's all the assumption here, assumption under this random effect. So what are the assumptions? Have to be homoscedasticity, independent of these two components, means that the two composite errors, right, have to be independent with each other, no autocorrelation, no group correlation, and then independent of the regressor. So there's a no, it means that they have an independent. So it's an important part. If they are not independent, then you have to use these fixed effect models already. That's diagnostic check we're going to diagnose this. This is the main concern. If there is a correlation amongst the residual together with these independent variables, then fixed effect will be preferable as compared to the random effect models. So this random effect, right, we cannot use the OS. It's different compared to the fixed effect. It's no longer use the OS to estimate. We have to use this generalized least square method. Generalized square method to estimate this equation, to estimate this approach, the random effect models. So let's go back to our models just now. We have the Y here, right? So Y here, and then a set of independent variables, and then this VIT. This VIT consists of the AI and also UIT. So in the fixed effect, right, we suspect that AI actually correlated with some of the independent variables. But if you can assume that this AI actually not correlated, then the model is preferable. That's model called random effect models. That means that when there is a correlation, among between this individual effect together with the independent variables, then in that scenario, random effect will be less efficient. If there's no correlation, then random effect will be more efficient as compared to the fixed effect models. How about if you compare the fixed effect, right, together, means that the AI, right, is it together with the explanatory variable? Actually, in that scenario, if they are not correlated, OS also will be consistent. That's why people call about the efficient versus consistent. Whether that's why we need diagnostic check to differentiate between the random effect together with this OS. So whether is it consistent or not consistent. Then we also use the Hausman test to test the fixed effect versus the random effect to see efficient or not efficient in that scenarios. So why? So this is a discussion, to finish that discussion about the correlation between the independent variables and also the AI. If they are equals to 0, right? So if they are not correlated, then we will prefer to use these fixed effect models, random effect models, if they are not correlated. If this condition hold, then we are prefer to use the random effect models. If this assumption violated, then we have to use this fixed effect. That is the general means that the story behind the fixed effect. It means that this condition. So what we're going to test is to test this condition. Are they affect each other or not? If equals to 0, then we prefer to use the random effect models because that one is much more efficient as compared to the fixed effect. So in the what we say theoretical basis now. So what are the advantages and also disadvantage with this random effect? So under the fixed effect, we also got the advantage and disadvantage, right? The challenges, right? So actually, also got consists of the advantages more degree of freedoms than the fixed effect, because we no need to estimate this intercept, right, for every cross-sectional unit, right? So we no need to estimate intercept, because we no longer use this dummy variable approach, right, to have to estimate them individually. If let's say I have 50 firms, I'm going to have a 50 intercept, right? So under this random effect, I'm going to have a more degree of freedom, because I have a less k, right? Less k, and with the same n, right? With the same observation. So I have a less k here under the random effect. So more degree of freedom. But what are the disadvantages here? So you have to assume the AI uncorrelated with the independent variables. We have to test it. We cannot assume we have to test it, right? Because is it this condition really hold or not hold? If this does not hold, then random effect actually is not efficient at all. So this is one of the advantage. One of the disadvantage, we have to test it. Whether is it really the condition hold or not hold? If hold, then we can proceed to use the random effect models. If not, then we will prefer to use the fixed effect already. So that is the story behind fixed effect versus the random effect. So it's based on the assumption. Each means that the fixed effect, right? Each cross-sectional unit has its own intercept. If we ignore it means that individual intercept, then we will have this aggregation bias, right? If you just allow have a common intercept, then we will have this aggregation bias, or we call it as a heterogeneity bias. And this random effect model, based on the assumption, intercept for each cross-sectional actually random one, right? Draw from a distribution centered around the mean. So it's just a random, and then that's why they treat it together with this. That's why we call it as a composite error terms, right? And each intercept is random, draw from the intercept distribution, and this is something like the random effect models, the error correlation models. So against the endogeneity, right? Endogeneity, if this endogeneity warrants, right? So because random effect models assume this heterogeneity is uncorrelated with the independence. If these assumptions not hold, then we're going to have an issue, right? Going to have an issue. The correlation between the independent variables and the AI is no longer equal to 0. Then we cannot use to estimate. We still can estimate the random effect, but we cannot draw the conclusion based on the random effect models. That is the thing. So that's precise already the analysis. And the random effect needs a specific assumption about the distribution of the random effect. So in some research, they got mentioned actually it's not that accurate, right? Because why we need to treat the random effect means that the individual specific effect has a random, right, to capture in the recitals. And if we follow this assumption, then it will be very inconsistent at the result. That's why that is one of the limitations, right, in this random effect. And efficiency. So that's why the assumption is very strong. That's why the story behind the random effect, the assumption for this correlation between the AI and also the independent variables actually is very strong. Equals to 0 is very strong here. Limited variation. You still need to be cautious about your independent variables. Because the models, right, the random effect models may not be estimate the coefficient accurately if you have the very static variables, static series. So actually this also apply in the time series, not only on the random effect or fixed effect on panels in the panel analysis. So even though in the time series, if you regress, right, so we have to plot the series before we run the result, then you found that how come the result so strange, right, so weird. Actually, when you go through the data set, then the data set actually very steady, right, very constant, no variation. So if no variation, actually very hard for us to estimate such a regression. So we can consider other proxy, for example, right? If you have others better data set, because it's a data-driven analysis. If we cannot get the reliable data source, then it's very hard for us to draw analysis, like right, for example.
I think it's like for time series, you want the data to be stationary. So less variation, would it be stationary?
You can think in that corner, in that perspective. Stationary means that not necessarily is a limited variation. Because it's reverted to the mean, right? You still have a variation, but not like just a steady only. Just not, for example, I don't think it's logic for you to have an analysis. For example, the series is actually 0.5, 30 years, 0.5, 0.5, 0.5, right? So it's very, when you estimate, then the result will be very weird one. Because it's referred to the changes, because our coefficient is the changes in the y over changes in the x. So the changes means that if you have 0.5, 0.5 for each data point, so what it means? It means that actually no variation in your interpretation, especially for the coefficient. Because the slope coefficient is referred to the changes in the dependence over changes in the y. So how much response for your dependent variable to 1% or 1 unit response in your y, right? In your x, right? So if there's no variation in your x series, so what is the coefficient stand for? That there is a variation. Stationary is different. Stationary means that they're reverted to the mean. They still have fluctuation, but not static. That is the thing. And the interpretation, right? This one, the coefficient is just an average effect on the independent variables. So now, how to choose? Based on this judge, right? Judge actually is an econometrician. They come up with the four possible something like the judgment, right? How to choose between the fixed effect, random effect. So if you have a large T means that you have many. If I focus on annual, many years. For example, like 20 years, not 20 years, 30 years, 40 years, 50 years. Very large T. And small n. Small n, for example, like 5 countries or 5 firms, very small one. In that scenario, fixed effect is preferable. Yeah, as easy to compute. Because small n, right, it just have a small n, just a serverless country or serverless firms. In that scenario, according to the judge, is a fixed effect is preferable. How about large n? So many n. For example, like n, like I have a 30 countries or 30 firms, for example, 30 firms. Then I only have 5 years. In that scenario, estimation can be different, right? So random effect is preferable in that scenario, right? Because I think one of the reasons is a degree of freedom, right? Because I have so many n, so degree of freedom also is one of the concerns. In that scenario, fixed effect is if not, right? If not, then fixed effect is preferable. So, but this is very subjective, right? How big is big? How large is large? How large is large, right? How small is small? Because for the people to proceed to the panel, I think the minimum n, right, will be like 5 countries, right? Above 5 or above 5 firms, 5 countries. So it's very rare for you to see the panel just have 2 firms or 2 countries, for example. So if 2 firms, 2 countries, one will just proceed with the time series, right? Then you can compare these 2 countries, what is the difference? So in order for you to rationalize behind to use this panel approach, you have to make sure you have the minimum n, like the normal convention size applied in the previous research, like above 5, 6 countries. So that's also considered minimum, like because like 10, that's enough, like 10 countries. In order for you to have a much more variation in your panel analysis. And this one, error term is correlated with the x. So this BI, right, BIT is referred to this, still remember the random effect and the backend got 2 components, right? One is the AI and also the UIT. So the combination is the error component, which is called as an error component, the BI. If the BI correlated with the x, so then the random effect is the bias, the assumption, the strong assumption proposed by this random effect, there should be no correlation between these 2. If there is a correlation, then you have to use the fixed effect already. That's why next we're going to use diagnostic test to test this assumption. And large n and small t, and this assumption behind RE hold, then RE is much more efficient. So if large n, right, and small t, right, and the strong assumption also hold, then actually the random effect is much more efficient compared to the fixed effect. So that is something like the guideline like proposed by the judge. Right? So eventually, diagnostic check, right? Diagnostic check. So with the diagnostic check, if the assumption hold, then we have to use this what we say the random effect. If the strong assumption hold under the behind this RE, actually random effect is much more preferable, right, compared to the fixed effect in terms of the. So now, using models, I hope you can know how to read the models already. So investment function, investment as my dependent variables, and then my independent consists of VAL, CAP, and then this is the residuals. This is just a general models because I just estimate the general models, right? So this does not tell you about the fixed effect or random effect, right? This is just a general models and for 10 firms. So now I'd like to estimate using the random effect approach. So now you go to the eViews here. You go to estimate, right? Choose the estimate. Then you change right the cross section here, because now I want to treat the AI as a random. Put that at the back there instead of the independent capture with the independence in the independent variables, right? So you mean in the intercept, right? So I just click OK. So this is my random effect models. What's that? Your eViews close. Estimate, right? You change your cross section become random. If you put it none, just a pool S. Right? You cross section here, just remain the same setting. Just choose the random. Cross section become random. This is one way of random effect models. Other than that, you remain the same first. Then you click OK. So this is my random effect estimation. Then, as you observe, the method here no longer OS. Right? It's called EGLS. It's a pool EGLS. So it's a cross-section random effect. It's totally different compared to the fixed effect because fixed effect here, not this one, I will close this one. This one also closed, right? I want to open this one. Where's my addition? So here, fixed effect, the method is this square method. But under this random effect, the method here is the pool EGLS. It's the GLS generalized square method already. So other than that, remain the same. 200 observation, sample correct. But how about the coefficient? Totally different, right? Negative 75. Negative 80, negative 58, right? This one VAL 0.10, but this one VAL 0.10 is same, right? CAP 0.30, CAP 0.3117, just a little bit different, but still different, right? Cannot be same, still different. So here for interpretation, how you will interpret this one negative 57.45 actually refer to the average intercept. Average intercept. So just like the lecture just now also talked about the average intercept, right? So how about the differential intercept value for these 10 firms? So for this 10 firm, how we interpret? How I get the this one GM for example. So you can say GM has an intercept which is negative 4.9. Unit lower than the common intercept. How can I get this one? So actually, the GM intercept is, we have to use negative 57.45 minus the negative 4.9. there's a GM intercept. We use this one minus the negative 4.9, you will get the GM intercept. So actually it's negative 4.9 lower compared to the common intercept, right? So we can say GM have the intercept value negative 4.9 lower than the common intercept. So you can see the random effect, the coefficient, right, will be different, right? So common one is this one. So it's a lower. How to get the common one? We like this. This is 57. 57 point. Typo here. 57. 57.45. So it's a lower compared to the common. So you can see which one is the farthest from the common one. So you can see difference, right? So there are different firms have a difference in the setup, right? Compared to the common 57.45. That's the thing, common. So we can draw. If we ask you to draw this diagram, means that the estimated models, right? Can you draw? You can calculate, right? Difference firms we have a difference intercept, and then but we have a same scope for the VAL and CAP. So you can see which one is higher investment values, right? As compared to you can compare GM investment value as compared to this AR. Oh, this is highest, right? Negative 170, far away from the common intercept, the GE. So you can see the difference of the GE and also the GM. So that is the thing, right? I want to show you the three different ones. Actually, you can summarize the coefficient in a one Excel sheet, right? To see the difference. So for example, in my lecture note, right, I'll show you the journal article as well. Oh, here. Yeah. So you can take a look lah. For example, this from the working paper, International Monetary Fund. I also uploaded the spectrum. So actually it's explaining the investment in the VNE and U countries lah, right? So that is so you can see this how people report the result. You can report the random effect regression. So it's an approach only, right? Approach, but their interpretation, right? Interpretation. So they start with a different model. Here got 9 models. 9 models. Why? Why not only one? Why 9? Because they don't know. Actually, the author don't know which models is correct models, right? So they report all the models. Then they compare the models. So if they compare based on the adjusted R-square, right? But not R-square, like adjusted R-square. So you can see they start with the one variables, and then 2 variables, 3 variables, etc. Then in here they try to drop out the growth, then they not include the economic freedom, not include the GDP, then to see the sensitivity of the result. This is one of the purpose, to see sensitivity of the result, and also maybe they want to compare the different models, right? To select the best model for the investment. So if you want to report the result, right, you have to complement the table with the notes. Because people don't understand, right, from what is this, yeah? So you can complement with the notes. You have to mention where is the dependent variables. Provide that means that you have to provide the details information for each coefficient. I mean for your models. Then also got fixed effect. So you can see the fixed effect and the random effect 0.127, 0.142, right? So that is the difference here to show the difference. But same observation, different R-square. But is it logic or not? The R-square is increasing, right? Yeah. Because the more information you put inside in each equation, you will try to improve the precision of the models. That's why the R-square is increased with the more independent variables. And now you can see, even if just one variables, the R-square is very low. But if you increase more variables, for example, in this case, the R-square is improving. becomes 0.41, for example. So the more independent variables, you will try to improve the precision of the models, try to increase the explanation of the models up to the investment. That's why it's increasing. But the adjusted R square is different. Adjusted R square will not be affected by the number of independent variables. So that is the thing. And also you can take a look at the details of the paper, right? See how they choose between the models. Yeah, that's the interesting part. This random effect and this a fixed effect. And then in this fixed effect, they try to report, right? Their intercept as well, right? You can take a look why they report this one, right? You see, Niger, Tonga, Mali. So you want to show the difference, right? Yeah, things. Also, the another paper can share with you, economic growth and FDI. So this one just want to give you some idea how the people applying this approach, right? So this is published in this economic analysis and policy. So actually there are more than that. This is I just simply download from the internet and then share with you how people can apply the panel. So that's how they report the result. It's much more different, right, compared with what we discussed just now. Just like same now, right? We just have two independent variables. So they have a model 1, right? Actually, they have a model 1, 2, 3, up to 7 because they're running the two ways, right? And also with they try to solve the AR1 because they're having the problem zero correlation. Then, yeah, the important thing here is this one, Hausman test. So this is what we're going to discuss next week, like the Hausman test to choose between the fixed and random, right? And also Lagrange multiplier test to choose between the random and also the fixed pool OS also. So how many countries they include here? 23 countries. Just now, how many firms we have? We have 10 firms, right? 10 firms, 20 observation. Here totally they have a 529, right? 529. Actually, it's a Hausman test. As you read the notes here, right? Just want to showcase you that the Hausman test, right? Actually tested now. Unobserved individual effects are not correlated with the explanatory variables. Do you remember? Just now we said unobserved individual effect, the correlation for the AI together with the explanatory variable, which refer to the independent variable, is there's no correlation, right? No correlation, V equals to 0. If we reject it, it means that the assumption is violated. Then we have to use the fixed effect already. That's why we have to have some challenge with the fixed effect, less degree of freedom, etc. Right? So next week we're going to use this Hausman test and test the things together with some diagnostic check as well. Right? So that's what we're going to cover next week. So there's a thing that actually you also can try to explore, right, the residual from my what we say Hausman test is here. Hausman test, redundant fixed effect. Then just now your friends talk about the diagnostic check, right? For these residuals. We're more concerned about the residual because we are dealing with the panel. So what we more worried about is the residual. Are the residual going to affect and then make our result not static anymore? So there is a cross-sectional dependence. Because panel, right, you're going to have a different, like we say, different characteristic. So the residual also behave differently, right? So are they going to affect each other? So if they affect each other, we have to use the panel to accommodate the cross-sectional dependence issue. That's why there is an approach that handles the cross-sectional dependence issue. So that's another approach. We not touch on we not apply this approach in the pool fixed effect and the effect. But we're going to apply that one in our panel time series next 2 weeks. Right? We also have a unit test, right? And a quantification test as well. This quantification test, right? Just like extension with the Johansson and Jusserius, but in a panel setting. Right? So let's say you can plot, you can try to plot the graph, right? Yeah, there's the residuals. So you can see the graph. By the way, if you want to plot, right, they are something like this is a residual series, right? Let me make it bigger. can have a residual for each firms, right? Because this is for my estimation, right? So you can have a residual for each firm. So you can see, is it very far away from their estimation? By the way, still remember just now we have the button like the common, right? When you go to estimate, there is a common coefficient. How about I want to see the individual? I want to see the, maybe I just want to get to know, right? What is the coefficient for the GM, right? So you can go to this one, right? You can type this one. Common one, you go to the cross section specific coefficient. Let's see whether workable or not, or not workable. So maybe I try none first. Let's see. Yeah, this one. Because I want to see their individual, right? Individual. So I can take a look. Okay, the constant coefficient, right, for the GM, the constant for the GM, and then coefficient for the GM, the CAP for the GM, and also the coefficient VL for the GM, just for the specific firms. Just for the specific firm. So the result show you the cross section result instead of in the panel format. But you have to draw the conclusion based on the panel, right? Because this is just because they use some technique to trick the AI, right? That's why they make it become the panel. But this is individual result. Are you going to have the same result? For example, just let me try that. Let me try and errors. This is my panel, right? I want to use the time series, for example. GM, right? GM. I open them as a equation, for example. Let me see whether I can send the same result or not. Totally different, right? Yeah. Because the constant for the GM is, here is negative 149. And then GM for the CAP is 0. Oh, here what happened? Sorry, I think something wrong. Let me see. Yeah, same. I also got weird. How come different already? Okay, come. So same, right? Yeah, constant negative 149, and then the CAP 0.37, VL for the GM 0.119. So they are same, right? They just pull them together and then treat the AI differently in the fixed effect as well as the random effect. So you can have a different result like for the panel approach. Okay? Are you still okay? Okay, right? Yeah. Yes. Okay, today we just have a short topic, introduce you with these three different models, so you can practice, right? Make it perfect. For example, if let's say, right, I just want to estimate 15 firms. 15 firms. So if I ask you to estimate 15 firms, you can go to view, right? Go to view. Go to view. Let me see. I don't think it's view. Let me see. Go to panel. Go to panel. Go to view. Cross-sectional identifier. Let's say I just want to say I want to estimate 15. Not say 15. Here are 10, right? I just want to estimate 8 firms without DM and G1. Just delete up, right? Just delete the GM DY. Then you just estimate. That is the thing. So you're going to have 8 firms instead of 10 firms. You just adjust here. Adjust here. let's say I say I don't want, I want to estimate this 8 firm, I don't want the US. So you just delete the underscore US, then you estimate. So then you just type the dependent, independent variables. Then you will get the 7 cross section, 7 firms. So there is the pool OS for the 7 firms. You can adjust accordingly, right? You also can adjust the time, right? So you become a 16 year with 7 firm, totally 112 observation. So that is how you adjust in this estimation in the panels. Let's say you suddenly want to say, okay, I don't think I need to put the GM because GM is a very big company in the US. So without GM, what happened to the result? Right? To test about the outliers also okay, right? So that is the something like things you can do in your research, okay? So okay, that's all. Do you have any more question? Do you have any question? No, no question. Oh, want to go back already, right? So let's check. So today we have just have a short section. So I will, next week we're going to test, right? We're going to test on this panel, and then we discuss about the variety of the tests before we move to the panel configuration, etc. Okay, see you all next week. Bye.